Everyone, good afternoon. My name is Omer Zohar, and I lead the research team at TopSIEM Security. And we don't have a presentation. All right. There we go. Well, the research we have been conducting in the past couple, probably past year, is basically trying to figure out what makes attackers tick, what is interesting to them in a scenario which is a post-infection scenario. What do they like, what they're interested are, and what helps them to move laterally across the internal networks. And if you can use it to our advantage as defenders and apply it by using deception. So I'd like to share some of the conclusion we did on the research today. But first of all, let me take you into one of the scenarios, the most common scenarios that we encounter, which is, all right, you're now as an attacker, you spend months preparing, gathering intelligence, delivering whatever exploits, phishing emails, whatever you want, and then you finally gain access to some workstation inside your target organization. Your target is now to move laterally in the network, find whatever you came in for, exfiltrate it, and walk away. So as you look at your first initial workstation, you find three different pieces of information that might help you move along. So what you got here, you got some juicy looking email with some admin URL, you got the credman with some terminal services for internal RDP, and you have some SSH to some cloud IP address. So let me ask you, show of hands, who think number one is the more lucrative? The more lucrative. Who says number one? Okay. Who says number two? I see almost no there. And number three? Okay, so it's almost a tie from what I can see of you. And so this is basically the question that we have been asking and trying to answer in our research. So what we're going to talk today is, first of all, why do we even talk about deception in a post-breach scenario? Then we're going to talk about our first ever research that we put deception to the test to test the effectivity of different deception solutions in all sorts of scenarios. I will show you a little bit about how do you employ and how do you build these detection devices. And then we're going to talk a little bit about our research results. So we're going to have fun. So why post-breach detection, and why do we even care? So everybody knows today that perimeters are patchy, and if given enough time, they can easily be bypassed. Then internal network are still a very chaotic place, multiple protocols, multiple applications, very little security, which leaves fertile ground for attackers to basically, once they're inside the LAN, to roam around and do whatever they want. As attackers, they have the most advantages, most of the advantages in the attack. They have the initiative, they have the veil of anonymity. Only they know what is their true target, and they have time to try and try again until they succeed. On the other hand, as defenders, we don't know who is attacking us. We don't know when the attack is going to come. We don't know if what we see is even an attack or it's a false positive, which happens a lot. So defenders, they have to end up defending everything from everything all the time. But defenders do have one main advantage, which is their inherent control of the assets in the network and the information on them. So if you prepare correctly and control the information on your network, you can use that in order to deflect a would-come attack that would allow to deflect attackers from your main assets into a detection mechanism. And one way that we do it is by using deception. So what are the deception and how does it work? So every network is built from its assets, workstation servers, IoT devices, the connection between them, network devices, whatnot. The deception mechanism that is called a decoy is basically the mimication of the assets on your network that will look exactly the same from the network standpoint. It starts from the OS fingerprinting and the internal network and the traffic, and goes up as you go up to in the interactivity level, to the protocol level, to the application level, and even to the data level. So once you do that, so decoys are basically, because they're not part of the operational network of the organization, there's not supposed to be any legitimate interaction with the decoys. So every time a decoy is being interacted with, it's a really very important alert that you have to deal with. Another advantage of the decoy is because they don't increase the attack surface of the organization. Once you lure an attacker towards them, you can employ it, you can delay it, you can study it in order to really understand and gain forensic information about the attack. Now, just putting decoys on the network does not mean that you will catch an attack, because sophisticated attackers will just, you can't wait for them to find your decoys. Sophisticated attackers will look at the workstation or the assets they're in. They will see what the user is doing, what sessions is he using, what software is he using, and will use that to move laterally and to go to his next hop. So to do that, in order to do that, we introduce another deception mechanism, which is called a trap. A trap is a piece of information that we seed on the real assets on the organization, and what they do is they put a reference or a pointer towards the other detection mechanism. It can be a decoy, and it can be other stuff. So once the attackers see this trap, and it's supposed to be something lucrative, something authentic, and really something that the attacker wants to understand what it does, it will act upon it, and it will reach our detection mechanism. So as I mentioned, the trap can point the attackers towards either a decoy, but it can also point them to other detection mechanism, namely beacons, which is a piece of information or a mechanism that is inside our trap, that once someone is open the trap or even exfiltrate it out of the organization and open it in another location, will beam us to us, and we know that someone has opened our traps. Or we can use some other conventional data analysis tools like SIEMs or traffic analysis to see the traffic that someone has been using, the data that we see on the workstation somewhere else. And then we know that there is an attacker on the network because he took our traps. Okay, so up till now, this was the theory. If you think about them, the deception concept is not very difficult. It's pretty simple. But when you start thinking about how to actually deploy a deception mechanism, some question may arise, like what sort of decoys should I place? Where should I put them? How many traps should I place in every asset? What kind of attacks are supposed to be catching with the decoys and traps? And if we can prepare to each and every scenario differently. As we grew in Topspin, as we grew and gained experience in deploying detection mechanism and deception strategies, we realized there is no textbook, there is no scientific answer to exactly what we do. So we decided that we're going to do a comprehensive research to actually test this stuff. We define three research questions. The first is, are decoys and traps effective in real-life scenarios? What kind of attack should I be able to catch? And what baits are working better than others? The second is, do attackers really take our baits? What interests attackers more than others? What types of baits working on certain types of attackers, and what doesn't work? And finally, is there a strategy, a rule of thumb that we can give our customers in order to increase the effectivity of the deception solution? So all these questions are really heavy and big, and we decided, we asked ourselves how we wanted to test the deception solution against real attackers. But we wanted to do it in a controlled environment where we can study them, study their action against the deception mechanism. So what we end up doing is a contest, a CTF. We build our own contest, and we invited our attackers to interact with our deception mechanism on our own environment. And this is how we build it. First of all, we build a whole corporate environment. We build servers, workstations, DCs, servers, and everything a corporate network has. Then we started filling it with lots of data, documents, emails, applications, everything to create a snapshot of a real live organization so that the attackers would have some interest and meets in it. Then came the deception layer, which is decoys on the network that mimic the physical network, and traps on the real assets to lure them into the decoys. Now we used, for this experiment, we used, of course, our own software, and a lot of POCs and ideas and theories that we wanted to test that we had on the lab, and some open source project that we wanted to see how they do. So we had a very big variety of deception solutions. Then came the challenge. The challenge was basically the attacker gained, we give the attacker access to one infected machine on the asset, on the network, using a remote access tool. And then his job was to move laterally, gain intelligence, and exfiltrate 5 pieces of information that spread around the network. We gave the shout out to security professionals around the world. Red teamers took part, hackers, pen testers, security researchers from all over the world, and to take part of the experiment. Of course, there were prizes. And in parallel, we also tested this environment against automatic malware, Trojan, APTs, bankers, and whatnot, everything that we know that they are doing stuff on the internal LAN or just stealing data. Our CTF ran for over a month. It's more than 50 security professionals took part. Each one spent 6 to 7 hours exclusively on the system. We analyzed 34 different malware samples and collected almost 2 million lines of log. So I'd like to share with you a little bit about what we learned. So as I mentioned, our CTF consisted of 5 parts, and we wanted to see how people were doing in each one of the parts. And what we saw is that the amount of time they took, amount of work they did in each one of the parts decreased dramatically as they progressed in the CTF. Now, it's not because it got easier. Actually, the first task, which was the easiest one, was just to find the data that they had to find was already inside the initial infected machine. So we thought it would be very, very easy task to start things off. Apparently, we were wrong. Why we were wrong? People just didn't know what to look for. They tried exploit, they tried to search for files, they tried doing all sorts of weird stuff. One guy even downloaded each and every file on the machine and checked it to see if this is what he looked for. And it's not like we didn't give out any hints. On our instructions, it was clearly said what to look for. So our first advice is, if you're doing a CTF, you should read the manual. But seriously, even though this test is a little bit synthetic, oh, by the way, people who did read this solved this first part in no more than 100 steps. So you see a big difference here. And when you think about it, although this is a little bit synthetic, this difference mimics the difference between an attacker who is prepared, who have knowledge, who gather intelligence, and people who just, randomly came about or just didn't do their homework properly. So they're the less sophisticated attackers. And by the way, we termed this phenomenon the knowledge gap, which is the difference between attacker's perception of reality and what actually is going on. We saw that the knowledge gap decreases, as you saw, as time goes by. As attackers gain more intelligence and get more comfortable inside your networks, and they get more familiar with, again, to know exactly where they're going and what they're after. And and we see the difference between a knowledgeable attacker who knows exactly what he's looking for and a less focused and less informed attacker. And when you think about in terms of detecting the attack, the wider this gap is, the wider the knowledge gap is, would allow you to easily detect the attack. Because when this gap is wide, then attackers will start doing more noise, they will do more actions in order to get to what they want, and then your chance of detecting the attack rise considerably. And this is exactly what the deception solution is all about, increasing the gap. Okay, before we continue with the results, I'd like to walk you through a little bit about how we constructed the different traps that we laid out in the system. We divided into 4 types of trap: file-based, network-based, credential-based, and application-based. And the simplest one is the file-based trap. File-based trap are the simplest, but the most versatile. Here you can have really good creativity about how to deploy them. So it can be something as simple as just some configuration file of an application with some URL, which is, of course, points to a decoy, and some username and password. It could be a document from the IT department on how to use the corporate LAN, the corporate VPN, sorry. Of course, every URL points to a decoy. But sometimes it's not enough. Pointing to the decoy is not enough. Sometimes attackers will exfiltrate documents from the network directly to their own premise and maybe look at them there. So what we did is we used beacons on some of the documents that contain some unique tokens. Once someone is opening this document, a beacon will either by HTTP or DNS query, depends on the trap, will ping us, and then we know by the unique token that someone has been touching or exfiltrated this document. We call these beacons. And by the way, when on our CTF, we used an open source project that is called Canary Tokens by the folk at Thinkest, which makes it very easy if you want to deploy your own canaries or beacons on your network. They even have a cloud service to do that. So beacons can be applied to files, to emails, to database traps, database triggers, and every possible piece of information that you can think of. Emails. Emails have the credibility of being important because they are a conversation between 2 people. They basically have the same functionality as files, but we saw in our experiment that they have the better credibility, and indeed, this email that was the most triggered trap on our CTF, which is just some kind of a SAP email that people were really interested about. So, as someone wise once said,
remember this: when you control the mail, you control information.
Yeah, he has a point there. So, moving on to network-based traps. So, network-based traps are really about how do we make attackers know about our decoys and let them know that there are other computers around. So the most basic stuff that almost any attacker would do to know who is these network neighbors on the local LAN is using the ARP cache. The ARP cache consists of a table of all the IP addresses and the MAC addresses of all the local LAN neighbors that this computer has been in contact with recently. So how do we employ deception into the ARP cache? So first of all, the most obvious thing, just add some static entries. This is very easy to do, but not very authentic. It can easily be seen as that it's static. Another way we found is by SIEM spoofing. What we do is we send a SIEM packet to some open ports at the asset. We send it from our decoy. What happens when you send a SIEM packet to some open port or even a closed port, it doesn't matter, some packet will come back, either a SIEM ACK or a SIEM reset. In order to know where to return the packet, the asset needs to know the MAC address of the decoy, and then it will generate an ARP request, which of course we're going to answer. And what happens is that the IP address and the MAC address of the decoy would be from now on the cache, on the ARP cache. Do this from all the decoys once every few hours, and you make sure that every decoy address and IP would be on the ARP cache. In our experiment, we saw that the attackers who used the ARP cache had 40% more likelihood of accessing a decoy afterwards. Application-based traps. Application-based traps are basically use of all sorts of applications in order to put lucrative information for attackers. The most obvious candidates are SSH clients, RDP clients, browsers, and so forth. You can see here some examples for SSH clients. So the applications can either you can either put them in the registry or files, depends on the application. Basically, the most difficult part of building this kind of trap is to reverse engineer each and every application in order to know exactly what is the data structure and where to put each and every file or each and every session, whatever data that you want to put there in order to do that. Fortunately, we don't have to do that because malware authors already done it for us. A lot of source code that has been leaked of all sorts of Trojans and bunkers in the past couple of years, most prominent was the Pony Trojan. It contains more than 200 applications, and all you have to do is just go to the source code, read what they're after, and do the trap yourself. So we know of more than 200 potential applications that you can trap. And finally, credential-based traps are basically all the traps that have to do with passwords and user logins in the Windows system. The most easiest place to put it is the Credman, which is not a very good place to put your passwords in because, as you know, a lot of people talked about it in the past few hours. Anyone with even a local admin account can use a tool like Mimikatz. You can't have a conversation in BlueHat without mentioning Mimikatz, of course. And you can see the password in plain text. So it's a very good place to put a trap. You can by default, every RDP password that you save on the Windows machine is being saved there, but you can do whatever IP address and port that you want. So this is the basics. The more sophisticated is actually injecting credentials into the LSAS. So we make it look like a domain admin administrator has logged into this computer, and again, with Mimikatz, you can see the plain password. Of course, it's not the real password of the admin, and you can use any user account you want, either if it exists or doesn't exist. And there is a unique password that every asset gets. Over here, we also use a cool open source project called Deceive by the guys at SecureWorks that they open sourced it I think maybe 6 months ago. And once attacker takes this password and sees it, he will try to act upon it. So whether he does it from the GUI or from the command line, this is just some of the stuff that attackers did on our CTF. So he would when he tries to log in, it obviously would be against the DC. There would be some network activity, and we will see over on the DC, we see that someone is trying to log in with this username. Because we know the password, a fast brute force would be done, and we can verify that he actually used this unique password that we put, and we know that he's been using he took our trap. Now, mind you that here we didn't use any decoys at all. We used a packet sniffer in order to know that someone has taken our traps, and you can do it also with the DC logs if you have access to them, and so forth. Okay, so to summarize this part, what are the guidelines of building a good trap? So first, as we saw, it has to blend in. What it means is that the traps you are building have to be authentic, and they have to be in context of the corporate environment you are in, and they have to look like something that the attacker wants and will help him as he progresses on his endeavors. Then it has to be non-intrusive. The hardest part and the time we spend most part in building traps is making sure that the legitimate user on the asset will not notice our traps, because if he does, he can either delete them, he can act upon them, and what you get is a false positive. So you have to make sure that although you make the traps like that they will be visible to a would-be attacker that uses his own methods, but not to the legitimate regular user. So you have to get a little bit creative here. You can put it we had many stuff that we thought of, like the recycle bin, temp folders, using the file permission systems, and you can just go crazy with that. And finally, you have to make it, you must make sure that your traps have a low attack surface. And that means don't introduce new vulnerability when you place the traps on the real assets, because they are on real assets, and don't introduce new vulnerability that will make your environment more vulnerable. Okay, back to our CTF. Through all the riddles and challenges, only one person was able to solve it all to the end, and he has a drone to prove it. And that doesn't mean that it wasn't catched. We didn't saw him, and he didn't stumble upon the deception. We just didn't entangle them enough so that he would spend all this time there. So let's talk a little bit about what we learned from our CTF. So first of all, let's see how our traps did. So out of the 340 times attackers took all kinds of traps that we put, you can see that the most popular one was file-based traps. But if you look at from the percentage of attacker standpoint, then application were most popular. Overall, 62% of our traps that we laid were discovered. We had very big variety of interest in the traps. The one that people consumed the most was 21 times, which is the PuTTY application app, with the session that we injected into PuTTY, which is an SSH client. But you see that on average, over here on average, each trap was consumed 3 times. And that means there is a huge variety in the interest of attackers between different traps. So no single trap is basically, you can say this is the one that interests everything and you can put only this one. We also examined the difference of behavior between human and automatic malware. So you can see that there is a big difference in the way they operate, where malware is more interested in an obvious way in the more structured data, that is in application, which is usually in the registry keys or something that machine could read. And human attackers were, from obvious reasons, were interested mostly in files, but we also saw emails and credentials and network-based stuff in high numbers. Each human attacker, on average, consumed roughly 10 different traps. So this is a lot of information, if you remember the information gap, that we inserted into the attacker's mind. And now the question is, what did attackers do with this information? So what we saw is that, mind you, that if you remember what I told you about the traps, no two traps are alike. There are some traps that gave the attacker very specific information, like username, passwords, and here's the service, and you can go fetch it. And some traps, like, they give general information, like the ARP cache that said, okay, you have IP address here, and this is its MAC. So what we saw is that attackers don't really use the traps the way you think they're gonna use them. So some of them ignore the trap data completely. Some of them act upon it and 2 hours later. Some of them meshed stuff together. They merged the data together. Some of them even gained more information, and they added on more information from what we told them by themselves. And I have a cool example to show you. One of the contestants in a CTF, he did a lot of interaction with our decoys. He spent, I think, few hours on them, and he accessed this list of decoy services. I think there's 10 of them here. So he was really interested in downloaded files and he entered those kinds of services. So we want to really understand what made him so interested in our decoys, because he spent a lot of time there. So we started backtracking, and we wanted to see if some of the traps that we had would lead them and to discover these decoys. So we started out with this email that he found, which says, okay, there's an email here, and they're talking about some RDP service in some IP. So he accessed that, fine. Then he found some FileZilla configuration file. FileZilla is an FTP client, and he used that. So he logged into, there are 3 here, so he logged into 2 of them. And there is a password that is hashed in each one of them. And the funny thing is that he didn't use the same exact password to each and one of them. He tried all of them on each FTP service. I don't know why. Can probably maybe typed in, made typos or stuff like that. But he merged stuff from together. Then he found another RDP service on .rdp file we had lying around, and then he found this email that I showed you before, which was our most popular trap. He found that. So all in all, we managed to find hints to only 5 of the services out of the 10 that he accessed. So what about the other 5? We don't know. There is no trap leading them. There is no. We make sure he didn't do any scanning by itself. So how did he figure? How do you figure these decoys exist? We can only guess, but I guess he thought, well, okay, there is a RDP service, so probably there's a Windows machine, so there's an SMB. He tried port 80 because, I don't know. And he entered all these services even though we didn't even tell him. He built this information. The story that we gave him was interesting enough that he built upon it on its own. And he spent more than 4 hours on the decoys, downloading stuff, and well, at the time he had to use this time instead of solving the CTF, and of course he didn't get to the end because he spent all his time on the decoys. So this is an example of how contestant attackers can be tangled inside the web of deception instead going after the real asset in the organization. Back to our decoys. A contestant interacted roughly with 10 different decoy services on average. You can see that the number of decoy incidents were in tens of thousands. It was very, very high, so a lot of attackers interacting with them. But this only tells half the story, because if you look at the histogram of how of how many times attacker consumed each decoy, you can see that there is a long tail of 20% of the attackers that actually did a lot more than just 10 accesses. When we investigated, we noticed that most of these interactions were what we call a low-level interaction. A low-level interaction is a SIEM or a ping packet or a UDP packet to the decoy, which many of you might probably guessed, which is a behavior that is network scanning. So people were scanning our network, obviously, but what you realize is when you have more than a few decoys on your network, network scanning is really a very noisy operation and can be easily detected. So people are doing scanning, stop. Okay, so even after we remove the low interactive events, we were left with an average of roughly 4 decoy interaction per attacker, which is still quite a high number, which means that attackers had hard time differentiating between real assets and the decoys. And we also compared the high interactive with the rest of the event. As you can see in the percentage of attackers, you see that there is almost no change. So between the low interactive and the high interactive events, which leads us to the conclusion that most of the attackers found the decoys believable enough, doesn't matter if they got there by a trap or by scanning. They found that they are believable enough in order to continue and interacting with the decoy and basically spend some time there. And of course, once you interact with the decoy, you're being detected. Your cover is blown. You can also see that overall, 66% of our attackers in the CTF were detected using the decoy, using different decoys. But if you look at the chart, no single decoy servers cross the 50% mark, which gives us the conclusion that there is no silver bullet in decoy. There is no single service that can show you and tell you that this is the most popular, the best one to put. You have to have variety because there is a big variety in the preference that attackers have when they do whatever they do. And finally, though the number of 66% of the attackers that we caught is impressive, you have to realize that this is not the only detection mechanism. Beacons and data analysis were two of the other detection mechanisms that we employ in the CTF. And if we combine all of them together, we get that over 100%, of course, with some overlap of our attackers on a CTF were detected. So just a small tidbit before we wrap it up. This is a conversation I had with one of the attackers because I had the privilege of giving each one of them exclusive access to the system. I could chat with them when they had difficulties. So this is an attacker that told me, I'm trying to get this file from this zip file, and I don't get what they want. He thought this is what he needs to win. And I said, why do you think this is the right place to look at it? And he's going, I followed some from history and email, and I have history of what, and he says, history of the Firefox browser. And then I knew exactly what he did. He followed a trap, he got to a decoy, and was very frustrated that it didn't give him the right information. So this guy just spent hours of his life chasing nothing. To wrap things up, the main takeaways from this talk that I want you to go with is, first of all, we saw the deception increase the attacker's knowledge gap. We saw the gap decreases with time as attackers spend more time on your network. And the goal of deception basically is to increase this gap and placing the bar as high as possible in order for the attacker to make more mistakes, make more noise, and we're going to be able to detect him and deflect the attack over to the detection mechanisms. Then diversity, which is basically the key to cover all types of attacks. No single trap, no single decoy, and no single detection mechanism will cover each type of attacker. And if you want to have full coverage with the deception solution, you have to have very big diversity of different deception mechanisms. And then remember that the final goal is not the deception by itself, it's detecting. So relying on multiple detection mechanisms, we saw decoys, we saw beacons, we saw traffic analysis over here, and you can think about more. So this is the key to really have good detection. So our friend Newman, he got it half right. It's not about who controls the mail anymore. It's about who controls information. And if you know how to employ it, only then you will truly be master of your domain. Thank you. We had if you are interested in what I told you today, we have a full report, more than 30 pages of actually describing in depth whatever we did here, and there are more examples of traps and how we constructed them if you're interested. And if